Good evening, everyone, and welcome to another CNC Router Mixer. So glad you could make it tonight. We do these every Tuesday night at 7 p.m. Eastern Time inside the hashtag CNC Router Tips group. If you'd like to join us, there is a link in the comments, and I'll put it some other places so you can find it. But there's no excuse tonight because I posted the link hours ago. Oh, how goes it, Telly?
Oh, everything going good.
Yeah,
Got off early today.
excellent, excellent. Welcome, Kurt.
Oh, welcome. I'm here.
Yes, yes, yes. We have the beginnings of something beautiful here tonight. So excellent, excellent. Um, really cool stuff happening. As far as things go, I know this is not router related exactly, but it is CNC related. So everything is game. Last week I showed you guys a set of plans that I picked up to build a fourth axis that would plug into my Tormach milling machine. And I got excited about that because it wasn't really difficult. You know, the stepper motor, driver, a harmonic drive, and then some machine pieces. And the most expensive part, aside from the electronics and everything, was a big block of aluminum to make the housing body out of. And I'm like, ooh, well, my local metal guy may have that if he's got some in. Otherwise, I got to order a 12-foot bar of
Wow.
3 inch by 6 inch by
Hmm.
12 foot stock, which is probably a couple $1,000 or something crazy like that. But I'm sitting there wondering, what am I gonna do? What am I gonna do? How am I gonna solve this? And I came across an ad for a guy who had some aluminum that was just the perfect size and the perfect length. So I picked up a couple of those, and uh, my first correspondence to him was, "Hey, could you mail some of these to me? Priority mailbox. I figure you could fit this many in there. Blah blah blah. Yada yada. You know how that goes, right?"
Right.
And he says, "Oh, I'm going through Syracuse this week. I could just throw some in the back of the truck and bring them to you." Ding 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 ding. We have a winner. So
Oh, nice.
everything's
Jackpot.
working out. Yep, everything's working out nicely. And the price was amazingly good. Amazingly good. About 1/3 of what it would cost if you could buy a single 6 inch piece of that material, which a 6 inch piece of that material tends to go somewhere around $100.
Oh. Hmm.
So, yeah.
So when he's delivering it?
Um, I believe Thursday.
Okay.
Yep. So life is good. Life is good. Uh, yeah,
That's
looking forward to that.
that's great.
Well, I've been promising a friend of mine to make some of these camera mount things that I've showed in the past.
Okay.
Um, and the number of operations I have to go through to make one of these camera mounts um, makes it a very, very long day. Very, let me put it another way. Makes it about a week before I get a significant a number of these done. And there's some other issues with the design that make it a little harder to manufacture. But with the fourth axis, you can put a piece in the chuck, rotate it, rotate it, rotate it, rotate it, and it's got four of your sides done in one push of the button.
Right.
Is what I'm getting at. So then you just have to deal with the end piece, which this one is not machined, but there's two more here, and the cutoff, and you're done. So I'm going from 6 or 7 operations to 3.
Okay. So mainly you just index it and it just yeah.
Yeah. And there's other ways around it. It's just um, the way I had it all palletized out to make these parts, I had one pallet where I'd lay the piece flat down, do the drilling and stuff, and then do the profile, then flip it, do the drilling from that side and the chamfering in the profile. And, now I've got a piece that's roughly the right size, but then I had to take it and move it over to another fixture to drill. And,
Right. Okay.
and it was like a series of things. So I put in a pallet of parts, and Mike got, by the time I was done, I had 4 finished parts. By the time the entire pallet had gone through the process, but there was a lot of flipping on that pallet. There's a lot of stopping, and anyway, was not a good way to make it, and it wasn't particularly consistent either. So I'm hoping that this 4th axis will at least allow me to fulfill this guy's desire and get his parts out. So, because he's a really cool guy and I like him a lot. So, anyway, that's got me excited. So I had to get that out of the way. So
That's nice.
yeah. So what are y'all working on?
I haven't
Well,
really,
I just posted a link. I got this stepper motor I'm going to try out. Although I don't know much about hooking it up, I have to see what I got to do. I just posted a link in the chat window.
I'm going to copy that into the Facebook group so they can see it too. And I'll take a peek.
that's pretty much that's an easy connection. It's just um what controller you use for
Well,
this?
I don't know yet because I
Oh,
haven't been able to. This is a little bit new. I got it for $20. I couldn't pass it, and
Oh
okay.
no.
so
Yeah, at $20 you can't pass those up.
No. Oh, you bought the stepper motors for $20?
yeah,
Oh, okay. How
I,
how many
I
how many?
well, I got one,
Okay.
and it was $20. I couldn't pass it, so I got it because I want to look into it. If it's $20, I can at least find somebody that might could use it, pass it on if I don't use it. But I want to get educated on these motors that have,
Integrated?
yeah.
This is the motor he's talking about. They're normally $90 here, which is
Mm-hmm.
actually a good price for this one, because I've seen them for more. These are closed loop stepper motors. In other words, they have an encoder and a driver built onto the back of these. So very, very much easier to wire
Mm-hmm.
than having separate components that you wire to each other. You make these 3 different wire connections and you're done. These are pretty good. You'll be surprised at how good they are. There was a Clow 52. Is that the name of the YouTuber?
42, I think.
Cloud 42. I'll find it in a second and we'll bring it up there. This is the type of motor I believe that he's using on his what do you call it? Is it automatic lead screw? I can't remember what he calls it. It's a partial CNC for his lathe without having a CNC computer. It does everything from a little microcontroller on the side
Okay.
of the lathe. But this is the kind of motor he uses. They're very quiet, very strong. So, meanwhile, Kurt, I'm going to let you continue talking about that while I look up Cloud 42.
Yeah, well, I don't know anything about the driver controller for it. I know it's got the driver on it, which makes it really nice, and it's got the tables and everything to go with it. I don't know what to use to control it though. So that's my project for the next few days.
What do you mean to control it? Are you trying to electronic lead screw is what he calls it, by the way. Uh, are
Okay.
you trying to decide between Mach or Acorn or any of those things, or what's the deal?
Yeah, it's a brand new thing for me. I didn't even have a clue where to start. I, um, what computer I need to turn it to even turn the motor. I don't even know yet.
Okay, it plugs in just like any other motor would to your Mach 3 or to a Linux CNC or to
Okay.
Massa or any controller software that does step and direction will
Yeah.
be able to
Oh,
control this.
You just
okay.
eliminate the independent driver. That's all.
Mm-hmm. So uh, I'm going to share the beginning of the video so that folks can look at it from Cloud 42, but I'm not going to show
Okay.
the whole thing because that's long. And I'll throw a link into the chat for the folks watching this on YouTube or on Facebook, and they can go and watch this guy. Maybe give him a like and subscribe because I like this guy's stuff. It's always informative, and yeah, I wish I could make good videos like that, but I don't. So I'm glad he does.
Yeah.
So let's start this at the beginning. Like I said, it's Cloud 42.
How does this $100 motor compare to the ClearPath? Let's find out.
Can you hear that?
I'm watching this one.
Yes.
Welcome back to Cloud 42. I'm James. If you've been following the channel, then you know we've been testing NEMA 23 motors for the electronic lead screw project so that I can come up with something that I can feel good about recommending. We've done some testing of open loop steppers, closed loop steppers, and even the ClearPath servo. And today I've got one more servo that I would like to test. If you're interested in understanding the methodology, I'll put a card up here. You can go check out the previous video and see the other motors that I've tested.
I'm going to give him his
When I
like
was
right
looking
now.
for motors to test, I did look at Stepper Online because I have purchased some motors from them in the past. In fact, that's what I'm using on my CNC machine. And I looked through the closed loop steppers that they offer, and there was one that looked really intriguing to me. And it's this new YE series closed loop stepper. They claim 4 Newton meters. That's probably holding torque like all the others. But the thing that's fascinating about this is if you look in the manual, they have this claim that says low torque attenuation up to 3,000 RPM. Now, 3,000 RPM is just ridiculously fast for a stepper motor. And for a stepper motor with, let's see, what do we have? 2.6 millihenries inductance. There's no way. I mean, there can't be, right? So I thought it would be really interesting to test this and see what what they're doing with this driver to get, quote, low torque attenuation up to 3,000 RPM. But I don't really want to spend my money for it. So I sent them email and offered them the opportunity to send one of these to me for free for testing. And this is the response I got. If you want to run the motor at 1500 to 3000 RPM, I highly recommend you use our integrated servo motor. Then they give some specs on the different motors. So for the 180 watt integrated servo, they're claiming 0.6 Newton meters between 1500 and 3000 RPM constant, and it can generate 3 times that for 10 seconds. So that actually sounds kind of interesting to me, especially if we run it at a deeper gear reduction ratio. So
Anyway,
I said, yeah, I'm definitely interested, and they sent me one. So this is the motor. It's a 180 watt servo rated up to 3000 RPM, 0.6 Newton meters, and this will run 20 to 50 volts DC. I think the manual suggests 36, but I spoke with them, and yeah, 48 volt DC is perfectly acceptable. You get higher performance at 48 volts with the expense of just a little bit more heating. So looking through all of this, this looks really interesting. It's just a NEMA 23 motor. It's got the integrated servo on the back. There are a couple things that are a little bit odd about it. It has, for one thing, it's got the pulse and direction input, but there's no enable input. I can live with that as long as it's not going to heat up when, like if I switch off the electronic lead screw, if this isn't just going to sit there generating a lot of heat or making noise, then that should be fine. It's kind of cool. It's got screw terminals to hold in the power connection. It's got your normal serial connection for connecting up the programmer. And then it's got a few dip switches to set a few things, but most of the interesting stuff you have to do via the serial port. So they sent me one of these, and we're going to test it. Okay, I've got the motor set up here on the test stand as usual, and before we do anything, let's just power it up and see how it behaves.
And I'm going to stop right after this.
Okay, that's on. It's holding steady. And the first thing I notice with this motor is that it's not really rigid. If I push it off center, it does return. It'll fight and come back, but it allows a lot of movement. Now compare this to the stepper motors, which don't really do this. If you press them hard enough, they'll eventually lose the torque battle, and you can cause it to lose steps, but they're very rigid in their position. And the ClearPath, once it's tuned, is exactly the same way. It's just solid. You can put as much force as you want on it, and it doesn't really move until eventually you overcome the torque capability of the motor, and then suddenly it just breaks. And this is very much not like that. This is very squishy, which, you know, is probably okay for some applications. I'm a little bit concerned for the electronic lead screw, because this means that when we enter a cut and the load suddenly comes onto the motor, I'm concerned that it will get behind and then fight and catch up, but by then the thread that we're cutting will be damaged. I'm not sure how big a deal this is, but let's get the software connected to this and see if we can tune this and make that a little bit more rigid, a little bit stiffer. I think stiffness is what they call it. That's what it says on the side here.
Now, to make a long story short, did solve that issue. It was a tuning thing. Once he got the right tuning cable, he tuned the motors up and everything was beautiful. In fact, this was a few years ago when he made that video. And he has been using his lathe for a while, and then he had the motor driver fail at some point, and he then analyzed whether or not he should continue using that motor or go, find something different. And the true result was, for the bang for the buck, for the use he had gotten out of it, and for the you see the performance is really good. He's like, I just ordered another one, and I ordered a backup when I did it, because what failed was a component in the driver that he could have repaired, but let's keep the machine running. They're commonly available, so there you go. And we all know electronic components fail much more often than mechanical or electromechanical.
Right.
So that's the long and short of it. I will post a link to that video inside of the CNC group, and anybody's interested, they can go and check it out, because he does torque ratings, he does all kinds of scientific stuff that I'm not doing.
Right.
And posted, and it's really informative, and you can see a little bit. He had some of the wires showing there on it, hooked it up. I don't know. I don't think that he went through it in this particular video where he showed connect this cable to that and this and that, but the instructions are very good. Did you get instructions with it, Kurt?
I haven't picked it up yet. I don't know what's all in the package yet.
Oh, yeah.
So the first thing I was looking at, I says, well, it's got all the digital things in it. And then when you hook it up, it's got the plugs, the little plastic plugs for it. And
yeah. And he only had one for $20, right?
Yep.
That's too bad, because
Yeah.
I would have bought everything he had.
Well, yeah, that's what well, when I saw it go up, I contacted it. I said, I want it right now, and I'll be over there to come pick it up in a couple of days. And he said, no problem. I said, how many you got? One. Okay, I'll take it. Jeez.
Yeah.
Yeah.
So go ahead.
I think that was one of the motors that I was looking at for my machine for the shop buy. Let me see. I'm going back and looking now, but I believe that was one of the motors that I was looking at.
Here is Cloud 42's YouTube
Yeah.
channel. I think I enabled it so that you can share if you want to, Tally. If not, then I will enable it. So let me make sure. Let me see what I did here.
Yep, it sure was. I added it to my Amazon like September the 2nd, 2024.
Yep.
Okay.
Yeah.
So we've actually got response inside the group. Hey, Cody from Cody's CNC Engraving. It says, hey guys, I rarely get a chance to catch these live. Thanks for going on this every week. You're welcome, Cody. You should join us, man. What do you got to lose? And you'll have a ball. The link, the link is in the post. Come on. You can do it. We'd love to hear from you. Anyway,
So anyway, I can hook this up to Mach 3, step in direction, and then is there any digital readouts in it or anything, or is it just straight through Mach 3?
Just straight through Mach 3.
Yeah.
And does it have error? Does it have error correction in it?
It's in the
I
driver.
believe, yeah, it's in the driver, but I believe what it has is fault. So if it goes outside of the parameters that you set, it will throw a fault and stop. But it won't lose your position or anything. But it does have an encoder, and it can give you real-time feedback about where its position is and things like that. What I don't know is if it is fully closed looped, because in some combinations you have a closed loop between the motor and the software, motor controller and the software, and some of them you only have it between the motor and the controller, and you want all three things talking to each other so that it knows where it's at. If you expect it to do things like error correct.
Right.
At least that's my understanding of it. Hey, Milo.
Yeah.
Hey, Milo.
Steve.
It's like my vinyl cutter has error correction in it. So if it gets stressed a little bit, it always finds its way back, and you're always right on the money.
Mm-hmm.
So that's like on my machine. It has communication from the motor to the drivers. But the Acorn is not completely closed. It's not closed loop. But the Centroid Hickory is.
Yeah.
But if you drive it and you can put resistance on it. Like if you try to hold the machine, you can feel it trying to move or trying to position itself where it need to go. But if you overcome it, it'll just send an error.
Yeah, and that's kind of what he was demonstrating in that video when he says, this feels kind of squishy, I move it and it goes back and everything. That was the servo. It's actually a closed loop stepper servo, whatever, saying my internal software tells me I'm at X1, and when you torqued it, I was at X1.5, and I moved back. And then you went the other way and I moved back. That's what it keeps doing.
Oh yeah, it bounces back to where it's supposed to be.
Yeah. Because it knows finitely where it's supposed to be, because there's so many graduations on the well, it depends on whether they're using a wheel or whatever, glass plate, or however they're doing it inside their encoder. But it knows where it's supposed to be.
Yeah, this one's got 1,000 steps in it. That's got to be accurate as all get out.
Yeah. Now the question is whether it can send that signal to Mach 3 and have Mach 3 auto correct. as well. And sometimes some software and some driver, it depends on what component you have that can pull it all off. Like you said, Tally, your Hickory could do it, but the Acorn can't.
Right.
Yeah. So anyway.
Well, I'll be getting in a couple of days here. I'll figure it out. Look at it over the weekend, and let's see what it does.
Hello, Milo.
How you guys doing?
Good, Steven. How are you? Welcome.
Doing well.
Yeah. Kurt just got a steal of a deal on closed loop stepper motor.
Yeah, I've been listening. You guys just went through Claw 42's video.
Yeah. He does great work, doesn't he?
I watch a lot of his videos.
Yeah.
Little too edited for me. I prefer more raw videos.
Well, that's what you get when you watch me. Yeah, I've decided editing is for the birds now. Yeah.
Hey, I did an 8-hour live stream last Wednesday, washing my little Cessna 150. I'm feeling it, man. I'm all sunburnt now, peeling.
Yeah.
You got a 150?
Yeah, I've had my 150 since about 2002.
What year is it?
1976.
I flew a 150 all over Louisiana at one time or another.
Yeah. So Steve was previously a commercial pilot at some point. Am I getting this correct?
Yeah.
And he just got recertified for flight recently. I don't know what the details were, but not as commercial pilot. And so he's rebuilding or redoing his Cessna.
Resurrecting.
Yeah, that's been sitting.
Hasn't flown in 8 years, so.
I haven't flown in 25, almost 30 years now.
Yes.
Wow.
So the cool part is he's taking us on the journey as he's washing it out and finding the squirrels or whatever. And, just here it is. This is what it's like if you're going to, refurb a plane that's been sitting on the hangar or sitting on the tarmac for a few years.
Yeah.
Mud daubers. Daubers, bird nests.
Mainly it's the wasps.
The mud, wasp, yeah.
I was gonna go do some stuff on it this week, but we're expecting rain all week, so it's like I don't want to get rained up. Work in the rain.
Right.
Yeah.
Our airport's not like a lot of the airports. A lot of airports, they have a rental hangar that you can rent for doing maintenance if you're either a transient or if you're a tenant that ties down. But our airport's very anti-repair. They violate the FAA's grant program terms and force you to go to the local FBO for maintenance. And I went rounds and rounds and rounds with the airport manager one year, and he realized that we can't force you to go to there. And the new airport manager thinks she can, so it'll be a fight.
Yeah.
And then they want to raise our tie down rates from $50 to $75 and not offer us anything more. They just sent us a note that stating if we want to pay by credit card now, we have to pay a fee.
Oh yeah, that's real nice.
Mm-hmm.
Jesus.
So yeah, it's politicky. So.
Yeah.
Yep.
That's a problem I wish I had, owning an aircraft, but I don't. It'd be nice. It'd be my dream, actually. A lot of people own planes once they have a very stable and how shall I say this? and disposable income. They suddenly become Planiacs. Uh, we've
Yeah,
talked.
they've got a money pit in them.
Yep.
They'll-
Yeah.
yeah.
Yeah. We talked about a movie producer who Tyler Perry. He went off the deep end for real planes and for model planes, and John Travolta, Michael Dorn from Star Trek. The list goes on. They're all like
Yeah,
multiple
Morgan
plane
Freeman.
owners. Yep, Morgan Freeman. Yep, just amazing. Uh, Travolta's got his mansion built around his airport.
Yeah.
Yeah.
Yeah, he actually flew for a Qantas for a while.
Hmm. Yeah. Can you imagine? This is your pilot speaking, Vinny Barbarino.
Jeez.
Yeah.
Yeah, I got a new tool. I have to share it. It's the cabinet. It's a horizontal laminar flow cabinet. It's basically it pushes HEPA clean air out the front from the back to the front. So it provides you with a miniature clean room environment.
Well, that's nice.
So if you need to do repairs on hard drives, you don't, because if one speck of dust on one of those platters of those hard drives, it just you won't get data off of that. And I want to be able to do exposed wafer programming. So all the programming has to be done in a clean room environment, which is one of these.
Mhm.
So
Do you find a solution yet for your camera tube?
nope, I just made a plug for it. Plugs right there. So I mean, binoculars work fine with a good set of lenses. But yeah, it's a I scored that pretty quick. It came from a compounding pharmacy, so it was brand new condition, all the paperwork, everything, and a fraction of the cost new. So
Yeah. Excellent.
but now I don't have to go borrow one. So you wouldn't believe how many of those cabinets are in electronics repair shops nowadays. Because if you want to do, like the glass on an LCD screen or something, any speck of dust will show when that bond gets glued down. So you want to have it super clean. And so a lot of screen repairs use those, data recovery, all sorts of companies use it. So, but I had to borrow one from a friend to do the thread repair on that microscope.
Oh,
To take it apart so dust wouldn't get on the prisms and stuff and contaminate the internals. So
you got your microscope repaired now?
all I need is a tube, and they
Okay.
flat out refused to sell it. And yeah, it's horrible. That's the only thing that's preventing it from being a useful tool.
Do you know what size thread it is?
M25 by 0.75.
Okay. So it's about a 1-inch thread.
Yeah,
Yeah.
it's a photo thread, but it's proprietary to them because a standard C mount is M28 by 0.75.
Okay.
So they made theirs purposely smaller so you can't put a standard one on there. And I made an adapter. I hopped on GitHub or not GitHub, but Thingiverse, and people make lens adapters on there. And I just plugged in the number and it generated me one, and I made it fit and it works. I mean, I just
Nice.
can't, it's not the right focal height, because if you add 10 millimeters to the height,
Oh,
you can't parafocal it. So it has to be
yeah.
the perfect, either have to shorten it 10 millimeters or go have it set down into the base the 10 millimeters. And so it's a custom part from them. So I've called microscope repair shops and everything, and they're like, yeah, M25 is an oddball thread.
Well, that would be if I had my 3D printer running, that'd be a challenge for me to try to build one. But what do I know? I mean,
Well, it holds two lenses. That tube has two lenses in there, and they won't tell me what power those lenses are.
oh man.
So it's either like a 0.3x, 0.5x, or 0.7x. It could be a 0.4x, but it could be like a 0.12x for all I know.
I wager an optometrist could measure it for you.
Yeah, that's what some people said. Go to the eyeglass shop and have them stick it in their machine if it's big enough. But it's a real tiny lens, it's like 20 millimeters, so it's real small. And I said
20
yes.
millimeters, like the size of a laser engraver size.
Yeah.
Are the lenses in the one that was had the threads ripped off? Are they lenses still functional and good?
Yeah, lenses are still functional.
I wonder if a laser engraver nozzle might somehow be, you know.
Yeah. They're usually sliding for adjustment though, aren't they?
Well, the one I have is you screw it on. It's about that size. Of course, I haven't measured it, but
Mm-hmm.
it's about that size, and it's got spaces for lenses you can put in there. You use spacers for the lenses to get the focal length out of it, but of course, I'm
That's
no expert at it. But
that's with the 3D printed adapter. I just can't parafocal it. So
okay,
you want to be able to, what I see with my eyes is what you want the camera to see, and all three of them have to be the exact same.
uh,
So it's either, take my head off and adjust it so people can see what I'm seeing, but then I couldn't see what they're seeing.
oh,
So because the focal depth is too high.
And the other problem is that the company doesn't sell just that part.
They will not sell just that part. No.
Yeah.
Even though it's going to do that, isn't it?
Yeah.
Even though they sell the one that for another model. Share. They sell this one, which is the half, which is 0.5 Barlow, which would be actually perfect for what I need, because that's you have to match your lenses, because I run a 0.5x Barlow on the objective side of my microscope to get more working distance and a larger field of view. So this piece right here would be fine, but they're saying no, they don't sell it separately.
they probably want $1,000 for that piece.
A standard one for any other microscope is anywhere between $50 to $100. So
there's always some reason to be a rascal.
they just don't know who they're messing with here, man. I'm a fighter, man.
That's the point.
I see Ned's about to sign in from sunny Australia. Very cool. Sydney, Australia. Interesting. Milo, what are you up to?
Oh, just cutting up some scrap, that stuff that you can't throw away.
Mm-hmm.
And
Good morning, good afternoon, guys.
hey, Ned.
Hello,
Hey,
Ned.
hey. Yeah, you better save that scrap for that future project.
Yeah. Yeah. You never know. Might be 30 years,
I'm
though.
guilty as hell. I'm guilty as hell of that one.
Yeah, I think I posted something that addresses that issue about a week ago.
Yep, that's the one.
Uh,
And I think it was Carl that was saying something a few minutes ago, or was it Milo? Did we have Milo on here?
Yep.
How's it going, guys? And it is nice and sunny here today. We're in winter, and it's a beautiful sunny day.
All right.
mm-hmm.
Driving home.
I was just at the engineering shop. I've done the first Z-axis plate for that CNC that I'm building. So I'm going home to fit it now. It's only the plate that goes on the gantry. I haven't done the spindle holding plate yet, or the spindle mount plate. Yeah, so I've got that sitting right here next to me. I'll just get on a bit of a straight.
I've seen that, Bill.
Breaking news: man used a piece of wood he put in the garage in 1982 because it might come in handy in the future. Film at 11.
Yeah, you sort of lose touch how much stuff you apply that to. I'm currently working on actually reducing a lot of that, particularly some of the fields that I'm moving away from it. Yeah, sporting is a problem. I don't have a problem.
Well, if all goes well by the end of this summer, I should be able to see the top of my desk, and
Get
looking forward
a
to
couple roll-offs in there.
Yep. So yeah, my wife says that's fake news.
I had to the excess. I turned a sideball again on my rotary,
Awesome.
and was making some game holders for like holding cards. And the senior center down here, they like playing Rummy Cube and all this kind of business. So I just take a bunch of scrap, glue it together, cut some slots in it, and they're happy. And
Mm-hmm.
get
Hold
back
that.
to those.
Hold that piece up again.
Seeing as you're taking care of all the elderly there with their ramekin and that, why don't you make them a round die?
Yeah.
Ned was talking while you were holding that up, so we didn't get to see it.
Oh.
Say something while you're holding it so nobody else.
Yeah, there you go. No, this is inlaid. This started out at 5/8 of an inch thick. Here, let me throw some pictures up here. Ned won't be able to see it. Well, or he's on the screen. Let's see. This was a scrap that I had laying around and just started gluing up random pieces, get them all the same thickness, glue them up. And these boards were turning into game boards. And they were about 14 inches of scrap, so I cut them off at 9. Well, you can't just throw away that scrap. So I glue it up into a block. And then okay, I was going to insert a inlay. And this is just a straight wall inlay. Cut it off on the bandsaw. Dump it into a piece of maple. And then cut that free. And then I inserted that into this block of wood. This is on a face plate. Just super glue down to that. And let's see what else have I got here. Need to do. I'll go buzzing through this thing.
Take your time.
Let me make sure I got this thing volume shut off. Not now.
This is on a legacy CNC router table.
Yes.
Mm-hmm.
And so here I'm going to, this is all programmed in Aspire. And I use the notes section. I think we've talked about it before to index it. So it's going to roll it over here to 45 degrees once it gets started there. Single cut off the top. And now I'm going to make a racetrack pass around here to reduce the height of that peak. And then rotate it 90 degrees, take off the peak. And the same thing, do another racetrack to further reduce it. That's an 1.25 inch surfacing bit. And so it goes pretty quick. And so this is all 3-axis programming with the added of, A45, A90 and all that thrown into the notes section. And then I'm going to switch to a 1/2 inch end mill. Don't need a ball nose for what I'm doing because I'm coming down beside it. And let's buzz through this tool change. Here it comes. That's probably measuring the depth. Oops. And then this machine allows you to turn on the rotary and just have it into constant spin, which is what it's doing here now. And now the gantry thinks it's a 3-axis job, but it's just cutting over a rotating piece of wood. It's rotating at 250 RPM.
That's pretty handy.
Yeah, it works out pretty good. And I've already modified the program because I should have had it flare out right here on the first pass because this is just a profile tool path going deeper. I was doing it in 4 passes and finally figured out I could do it in 3, plus pull away a little quicker. And I cut it down from 3.5 minutes to 2.5, well, 4 minutes down to 2.5 minutes to cut the whole ball out now on the new modified. So it's just going a little bit deeper, keeping coming around. And now it's going to go down a little deeper. Make another pass coming around. This is moving forward at about 6 inches a minute. I think 8 would be okay. It starts to do a bit of a spiral groove on it. So 6 gives you a very, very clean finish. And here it pulls away from it so that it doesn't leave a mark on it. And here it's doing the last pass for the full half sphere. And with the 5/8 inch deep inlay, that way you don't cut through it. I still got about 1/4 inch of inlay into the material here after it's rounded out. And if you wanted an inlay on all 4 sides, it'd be real easy to do, or you could put it on 8 sides after you take off the peaks. Okay, now here I'm going to do a relief cut on the back side so that when on follow-on cuts, it has a place to escape into so that it doesn't sit there and rattle. This is a 2-inch long down cut spiral end mill from woodpeckers. Their bits are very well cut. And now See, I'm cutting uphill on the other side, and you get way less tear out. And you can see there's a few chunks floating around, but most of this is pretty good chips. And we'll go buzz through these here. There was 4 passes. If your y-axis is not dead center over the top of this, you'll get a registration mark here that, if it's off one side, one half of the ball is going to be bigger than the other half. And so you move the Y by half the difference to get this to blend smooth. And now I've got this, you can see, let's see, come on, pause. It doesn't want to pause. Right over here, I've got a mark that sets it up. Now I'm going to cut it off here and just cut it off completely, and it gently falls into the bay there. No damage to it. And when you pick it up, the only thing left on this thing is a very, very small nub.
We still see it as paused, or at least I do anyway.
Oh. Okay. You see this
Nice.
here? Yeah, for some reason it on mine didn't pause. And so that's the nub that's left out of all of that. And let's see here. To clean up that thing and to finish sand it, I could rig it up on the CNC, but here I'm on a lathe between centers and just sand off the nub. And then end up going to a Sorby inertia sander. And there's no, it's just working off of the rotation of the piece. Does a great job of sanding, but you can tell here, there's no wobble in it. This thing is turning dead true. And then I'll take and rotate it 90 and then sand it again. And by the time it gets done, it was, I'll take it down to about 300 grit. And it came out really nice. I think total time on the machine was 7 minutes. And here it took me about 10 minutes to sand it. So about 17 minutes from start of cut to finish of sand. Turns out that this 3.5-inch ball is also the size of croquet sets. The guy was going to make a croquet set for a person. And he said, hey, this ball is already the exact same size. I thought, okay, for what I know about croquet.
I got a suggestion for you, Milo, which will trigger your OCD creativeness.
Yes, sir.
I just got distracted on a phone call, so I missed the last couple of minutes, but I saw how you were assembling and rotating the ball and so on earlier. And what I said earlier was, why don't you make the elderly that play Rummikub a round dice? And what was crossing my mind while you were machining the ball was, if you got, I'm not sure what they call those drill bits, but they're the ones that sort of do a round rebate. Is it a mortise drill or something like that? But anyway, if you got a 3/4 or even pocketed something like a 3/4 hole on the side of one of your spheres when you make it, and then pocket another 3/4 hole on the opposite side, that will then give you a 90-degree offset center that you can then rotate the ball, and you can put those same pockets in the end where you were initially holding the ball. And you can make yourself some rounded plugs that go into the sides, and you could do a 6-sided dice. And then you put it in that machine that you were polishing the balls up with. That was pretty clever, that actually. And polish it up, and you could end up with a round dice. Doing a 6-sided round thing.
Yeah, the during COVID, I created a bunch of these, old people in nursing homes and retirement homes, and they're losing the dexterity in their hands. You start out with a kid, you don't have dexterity, and you end up as an old person, don't have dexterity. So I have places to put cards so they don't have to sit there and try to hold them all. And I've probably made 50 or 60 of these that I've given out to different homes. And, they like playing their games. And it's, scrap wood. It's a good recycling effort.
Good to see you're green.
Yeah.
Milo, how does your rotary axis turn continuous? What does it? Is that the controller?
Yeah, it is. The Legacy made a deal with Delta.
Okay.
And that was the first thing they asked Delta to include in that controller, was to be able to turn that independently to mimic a lathe mode. And they still need to do some more refining on it.
Okay.
But I can turn it on and off and control the speed. I want them to be able to control the direction as well. They currently do not have an acceleration and deceleration on it.
Okay.
So more than likely, you're going to skip a step when you start and stop. But a lot of times you can work around that. Do anything that requires indexing, positional, do that before you do this constant spin. But, there's been people that mount a doggone lathe on a table and then have their CNC do that same thing.
I was actually going to ask you, once you put it into that spin mode, can you stop it and then go back to where you were index sort of thing? Sounds like you can't.
Yeah, no. The funny part is with the way they've got it programmed, I can control the speed of the rotation above what I can do as a rotary axis, with all three axes doing a coordinated turn. About the best I can do is come up to about 170 RPM. This thing I can go to 300 or 400 RPM. About 250 seems to be a sweet spot with the bit at about 14 to 16,000. Same thing as you'd do on the flat. But there is, side cutting is a lot better. It shears off the wood much cleaner than a top cut. And I think the biggest thing, like on a stair spindle, cutting on top causes a lot more vibration. Because I think more of the bit's in contact. Whereas if it's, around one and you're down on the side of it, you got a knife edge in contact with that wood. And with a spiral bit, it's shearing that wood off nice and clean. Way less vibration. And programming it on the side is easier than easier than I first thought it was. I'll pop up an Aspire file here. And of course, it doesn't have to be Aspire because I'm not cutting on a 3D model. And okay, there we go. I draw all this crap out because I need to be able to visualize. These are these 1.25" servicing bits taking and cutting off the peaks. Here I wanted to make sure that I had clearance for that 2-inch bit to come down just past the center arc of that ball. And you can see here, if I didn't knock these points off, it'd come around and hit the doggone spindle anyway. And right here, if you were looking down on top of it, here's the faceplate, here's the block of wood from the top down. And to cut that ball off, let's turn on solid preview. Here is the vector. I sweep in on it so that it gently engages the wood, and then it gets around here to the side, and then I sweep away from it. And that way, if there's any extra wood on there, it does a nice clean approach and departure, and it works out real well. And this is just a single vector. At the video you saw was a 4 passes. Let's turn off some of these. And here are the 4 different passes that it's taken as it's cutting down. It isn't moving over to the ball or anything. It's just coming straight down on it. And that's all there is to side cutting on this thing. And this is actually a 3-axis job. It had there's really nothing on here that's a 4-axis job at this point. To cut the corners, see right here is a single. Now what I did, let's turn off this. My 0 point is out here at the end of the block. Most of the time you'd be zeroed off over here. Well, the blocks they vary a little bit, on the width, whatever scrap I'm putting up here. Well, I found out that zeroing here made it easier for me. This single vector here is to knock off the point, and then the racetrack cutting on the line and just going around to the depth of cut that I was after up here. First one is at 4/10 of an inch. The second one is 8/10 for depth of cut. And even though, let's see, is this a 4-axis job? No, this is single-sided job. You can mix rotary work jobs and 3-axis jobs on a rotary job setup. Because if you put it out to a 3-axis post processor, it doesn't care. Doesn't know the difference. And with that thing spinning, if you're doing a oscillating shape of a spindle, all you're doing is tracing the outside shape. But yeah, pretty straightforward to this. Where I was talking about, I got to make myself notes. And if I put these notes somewhere else, when I need them, I'm going to lose them. I'm going, where did I put the instructions on how to do this stupid thing? So right now I'm putting notes in my file so that whenever I open one file, and I got all of my notes here. Even here, that if I have this shifted on that sphere, where one side is bigger than the other, I said, okay, the Y0 has to move that way on the machine. If the front is smaller, I got to move it this way. And then it's kind of weird, but it corrects them both at the same time. This is where I was making an 8-ball. And
Kelly, remind me to tell you about
that's that one.
the ClearPath servo that'll solve that.
Oh,
Yeah.
okay.
But anyway, let me keep going, Milo.
Yeah, this is the 8-ball. I just cut a couple pins and sockets and put them inside of the, it takes a couple cuts because you're cutting into the other hole. And that's the 8-ball.
Oh, that's nice.
And this is just a bunch of scrap cherry that was left over from another project.
It's nice to actually see an 8-ball. I've been behind one ever since I can remember.
Yeah,
But,
yeah. Yep, I have.
Oh man,
But
that's
yeah,
beautiful work.
this
What's
is what
the
happened.
finish?
That is polyurethane. And I always use Minwax polyurethane oil base
Mm-hmm.
because you can see where the reflection of the wood changes as you move it around, and it does a heck of a nice job. Uh, Ladies are the buyers of a lot of my stuff. Guys like to have satin finishes.
Mm-hmm.
Ladies like to have gloss finish.
Mm-hmm.
Almost across the board. And
Interesting observation.
yep. And I go, wait a minute, guy. Because I had several guys say, I don't like that shiny finish. I said, you're not the buyer. I said, you guys think you can go out to the garage and make one yourself, and you're never going to pay for it anyway.
Mm-hmm.
I can make that in my garage. Well, here's a pocket knife. Go for it.
Yeah, I'll be here next week. Bring it with you. Show it to me. Yeah. Love to see it.
Well,
Yeah. So
with the
go ahead, Ned.
I think there's a little bit of a delay with my internet at the moment for some reason. Yeah. But what I was going to say is I've started using wipe-on poly or polyurethane myself. I used to use oils and stuff like that. But what was pointed out to me was that the wipe-on poly doesn't discolor or very minimally discolors the wood, so you get the more natural look of the timber, where the oil changes the tone or the depth of the wood as in darkness, makes more timbers darker and changes their I don't know whether you want to use the word brings out the color, but just makes it very dark sort of thing.
Yep.
yeah, I've found polyurethane is way harder finish than like lacquer. I mean, a lacquer is easy to repair, but it doesn't hold up for me. If I throw this on a buffer, I can burn through lacquer before I can blink. Whereas this polyurethane, I can get pretty aggressive with it and polish out any imperfections, and it's still there.
Yep.
Whereas it's so easy to burn through lacquer that if you're not paying attention and you blink, you just went through it and you start over again.
Mm-hmm. I want to get back to something that Tally mentioned earlier. When Tally was asking you about your legacy machine and how it was rotating constantly, it reminded me that a lot of us are using ClearPath servos for some things. But ClearPath has many different styles of servos and many different brands that do different things. And there is one family in there, I think you can probably do it with the ones that you commonly use, that allow you to set velocity that it will spin constantly. It's one of the different modes. You have to just tell it to go into this mode, which I think you can possibly do with a G code, or you can do it manually. But that will allow for it to spin versus doing step and direction. I've got a quick video just giving you an idea of what that looks like. Now this guy's using the manual control. Let's see. For this. But that was the demo they did with their ClearPath servos and the included software that they had. But they've also, you notice how there's indexing slots on this wheel? They also do another demonstration where they have another ClearPath servo hooked up to a linear slide with a pin on it.
Oh yeah, and they slide through.
Yeah, it goes back and forth and through this pin. But you wrap up and down to different velocities or whatever. I think these, these are the MCVC version of their servo. Anyway, just food for thought if you want to roll your own. Where is it? Rotary axle.
Yeah, because Milo and I have the same motors on our
Mhm.
machine. That's why I was asking about that because he has hybrids also, you know.
Mhm.
And I was asking if that's why I want to know if it was that controller doing that. I can get mine to spin fast, but it has to be through G code. Like
Yeah.
it doesn't do it through the controller. I can just tell it to continuous to rotate. I was trying
I,
to figure out
yeah.
if
And
it's something I can do.
when Delta made this thing, they created a custom G code. They call it G200.
Okay.
And then there is a second portion of it, which is an A, and then that's the speed. So a G200, A200 would be 200 RPM.
Okay.
And I'm trying to get them to say, okay, let me go a positive and a negative. Because right now it's only a clockwise rotation. I said, there are times when I'd rather have a counterclockwise. And the speed I can do, but they also need to do the acceleration and deceleration. I think they were just trying to get it out the door, that Delta programming, which you can't blame them. They got other things they got to do as well. But to tie in an acceleration, deceleration so that you could rewind it back to zero to maintain your index point. But
Um,
I talked to Legacy as well as I said, hey, if I'm up to 400 or 500,000 degrees, I don't want to rewind this stupid thing back to zero. I want to divide by 360 and rewind only the remaining portion. And I guess some controllers will do that because yours will do that,
Yeah.
Telly.
Yeah. They Centroid integrated, but at first I had to write the code for it. Like it didn't do it. I had to put a code inside my post processor for it to do it. And then Centroid caught on to it, and then they allowed it to do it with the new updates. Because that was annoying. Like that was really aggravating. Cutting something and then it got stuck at um I don't know how many degrees. Sometimes it depends on how I set it up on the controller, but it'll say like 3 revolutions at such and such degrees, and then what it'll do um when it went back, it unwind all those degrees, and the z-axis will move up gradually instead of just raising up in a rapid movement. Um,
Yeah,
but
this constant spin. I mean, you can easily get up to 5, 6, 700,000 degrees. And now what I do at the end of it is I got it in the doggone post processor where I just do a G92A0 and reset it back to zero wherever the heck you're at.
right,
And then if I got a follow on indexing position that's critical, then I re-zero it, manually. But
well, I was going to say, if you, there is a couple of solutions for a few of those problems. If you wanted to do something manually to start with yourself, because that was one of the questions that I asked and what I picked up on with what Milo said earlier is if you put a switch on the input to your rotary axis on the direction and pulse, and then you feed in a manual direction and pulse using a 555 timer or anything that generates a square wave that you can adjust the frequency on, you can do a manual pulse generation to turn the stepper motors. And then when you need to re-zero them, if you create a good, reliable, accurate rehoming on the rotary axis, that will put you back within 2 or 3 decimal places of where you started from. That would be a simple way around it.
yeah, I like that idea. Because the more I side cut, the better I like it. It really does a lot better cut quality. and less sanding is a good thing. I mean,
Right.
it's shocking the difference than cutting on top. And the ability to switch sides as to what contour side you're following. You know, you got to cut uphill with the spinning bit. So sometimes it pays off to jump to the other side and go head to tail or tail to head on the other side.
Hold on, I'm gonna post.
But yeah, the setup inside of like Vetric, it's very simple. Once you almost can't believe that it's as simple as it is. You know, if you get it down to where you are thinking, hey, it's only a 3-axis job, but you're restricted to the center portion of this line, you're just trying to stay away from the line, the shape that you're after.
That I just put it in the chat. That's the code that I had to put in. So M151, yeah, /B, and then a G0B0, and then it returned it back to 0. Whichever, so it didn't matter if it turned 270 degrees. If it was in between, it'll turn to the nearest 0.
Oh, that'd be nice.
Yeah, so it didn't unwind. It just turned to the nearest 0. And it canceled out whatever degrees it was in. It canceled it out and just go to the nearest 0.
And that's a peculiar thing within Centroid.
Yes, so this is what I put in my code first. So this is in my post processor. Now, Centroid has it. Dang, I wish because Centroid actually has the command tab at the bottom in the controller to do it. I still use this in my post processor because when I finish my first tube path, I want it to automatically go back to 0 before I start my next tube path.
Right.
Yeah. So it'll do it, and then the Centroid it'll correct it. Like even though I have it in the code, then Centroid will automatically correct it, and it'll be back at 0. And you'll see on the DRO where it changed from, it might say 5 rotations or whatever at 280 degrees. And then what it'll do, it'll automatically go to 0, and then you'll see the DRO go back to 0. It'll just change it to 0. So that was one of the big things that we was troubleshooting doing. I want to say they fixed that in like 5.18 version or something like that. Now we on 5, we on 5.30 now. So it's been a while since they have integrated it, but it definitely makes a difference.
I'm kind of
Actually,
wondering
you know
if
what
Ned brought enough to share.
Uh,
Yeah, I seen him stop at the convenience.
I had to pick up my diet fix for the morning. What I was going to say is the reason why Tally can probably do it is his axis has probably an absolute encoder on it.
We were talking about this last week, Tally. Absolute. Yep. Go ahead. Go ahead, Ned.
No, I was going to say the reason why Tally's code can do it, go back to the nearest 0 either way, is an absolute encoder would do that.
Yep. Speaking of which, I was looking at that. You know how it goes when you start this thing. I had to go find that ClearPath motor, that the specific brand that does the constant rotation with everything.
Right.
So I did find it, and I will share that with you guys. And here we go. I think this is, did I grab the right one? No, this is the right one here. Um, can you hear that at all or no?
No. Oh, now I can.
ClearPath MC is the easiest to use industrial quality servo system available today. To use ClearPath MC, you simply select your desired operating mode to control velocity, torque, or position, enter a few motion parameters such as maximum velocity and acceleration, and then motion is controlled by using only a few digital inputs. These digital inputs can be supplied by a PC, a PLC, or even simple switches and knobs. For many applications, there is absolutely no programming required. ClearPath MC models have up to 10 different operating modes to give you maximum flexibility. You can control speed manually, ramp up or down to chosen speeds, make incremental moves from your current position with the push of a button or pulse from your PLC, and there are 7 other operating modes.
Move to absolute position, spin
ClearPath
up.
MC is available in 2 different models. The ClearPath MCVC model is typically used for speed or velocity control applications, often as a high-performance, cost-effective replacement for AC induction motors. And the VC also has a torque control mode and a basic back-and-forth positioning mode for users upgrading from pneumatic cylinders. The ClearPath MCPV model has all the VC modes, plus a greater variety of positioning modes. So the PV is generally used for point-to-point positioning applications.
Video can't quite keep up with the sound.
If you don't need the more advanced positioning capabilities, the VC model will save you some money. And in all cases, you get smooth, quiet, bidirectional, and precisely servo-regulated motion in a low-cost integrated package. NEMA 23 ClearPath MCVC integrated servo systems start at only $254.
We get the idea, I think.
And the MCPV models start at $314.
I mean, it might be an affordable way for
each different
people that just want to be able to spin that son of a gun on command.
Yeah. And that particular line of motors that they're using, I don't know specifically. They say you can control it with PC, but nothing indicated that you could control it with step and direction on that. And if there is some hybrid mode or some, one particular in their line of many different motors that they have that will allow that, then that would be fantastic. But when you're doing your cutting with the Legacy, you're not stopping at mid spin to change rotate 5 degrees or anything like that. You're just spinning, correct?
Yes.
Yeah. Okay.
If I'm doing an indexing operation, I do that all within Vectric.
Mm-hmm.
By passing the G code through the notes section, just so I don't have to manually edit the G code. And
Gotcha.
To where you can say, A90, A45 to snap it around. And that works very well.
I would love to hear from somebody at Technic, the company that makes the ClearPath motors, if they had something something that bridges both of those worlds, because it would be, really nice to be able to, spin it or step it in the same motor. And maybe I just don't know enough about it to it's and somebody will be making a comment. Yeah, it's been doing that for years. So,
Yeah, probably.
Actually, actually, another thing just crossed my mind. When you operate a CNC in lathe mode, you only have a single pulse, but I think you'd still need a servo motor for it, not a stepper. But when you operate a lathe, to index a lathe, they don't have an absolute encoder. What they do is they have a single pulse. And I'm just sort of thinking thread cutting on a CNC lathe. And basically, they know where the zero is, and then the machine counts the pulses from that pulse to where to start cutting the thread. So there might be an additional bit of G code when you actually switch an access to lathe mode.
Well, and Ned, you said something earlier. I don't know if that's what you meant or that's what I heard, but I kind of like the idea of putting a doggone proximity switch on the rotary.
Yeah.
To where that's your 0 point, and no matter where you're at, go back to the 0, which would still take you to the nearest circle or the nearest one rotation.
That's what I have.
Absolutely, yeah.
That
was a simple solution. Yeah,
I have a limit switch. I have a limit switch or a homing switch on mine.
Yeah, and then if it's up there to 500,000 degrees, just come back to the home location and you're back to 0 again.
Yeah, that was my simple solution for it. But it would be nice to actually using the program without doing that the machine actually knows where it is all the time. And I think the secret might be in the lathe lathe mode, CNC lathe mode, rather than 3-axis milling. And you might be able to incorporate it in some way.
Yeah.
What? Okay, so let's go back to we have both of us have Lee Shine hybrid stepper motors, which have the encoders in it. Okay. If you ran it in incremental, would it know its position?
Unknown to me. I don't know.
Yeah.
Yeah. Something to test.
Would it, because we was discussing, I was discussing with Bill and I was discussing with Milo today is that, the these new machines now, they come in without limit switches or homing switches. Especially if they are built with servos, they're programmed in incremental. So like your Scour, they had two machines. They had one machine that was a 3D printer, which was one of the fastest 3D printers that I have seen. And they had a claw, like a claw type machine that you pick up the little like little toys, out of the it had no limit switches or anything on it. And I asked him and he said, well, because the servos, they knew their position all the time, so they never needed homing. But it was ran in incremental mode.
Now there must be a startup position for these things, or I guess I don't understand how it would know where 0 was when it lost power and turned back on again.
That's what I was wondering. I'm wondering if they programmed it. Let's say, in the start of the day, if you push your machine into a designated area and you said that was 0 to 0.
Yeah.
And you ran it in incremental mode, it should know that position automatically by the encoders. That's what I'm thinking.
Right.
And then it wouldn't need to hit any home switch because you program it to have some arbitrary home that it remembered to the encoders. So I was wondering, even with I wanted to try it. I was gonna set my machine up because I know I need to change. I need to change the controller to read an incremental, and I need to change my post processor to read incremental. And then I was gonna try it and actually see what it does on my machine, if it'll act right or if it'll crash.
Did you ever read anything that what would be the advantage to incremental over relative?
No,
Or
I looked at some videos today. So a lot of guys that was doing like machining, they say the only time they use incremental is they're doing like drill patterns. If they're doing drill patterns,
Mm-hmm.
so they'll know if they might do.
Oh,
Huh?
sorry, I know exactly where you're heading. Yeah, no,
Oh,
that
okay.
you're absolutely correct. What it is when you do when you let's just say you went let's just say you had a datum, and then what you would do is if you had a hole at 1 inch, you'd go x 1 inch, and then if your next hole was at 3 inches, you would go x 3 inches, and
Right.
that will always take it from that single zero. But if you're already at your 1 inch hole, you can say, and mentally you know that the hole is 2 inches across, and I think that would more so apply if you're using MDI. You could just go in x 2 inches, and then it'll just move 2 inches across from its last position. That's the only difference between incremental and differential mode.
Right.
I mean, is the advantage less distance, so less error?
I think it's got more to do with how you think and how you program. And I think it goes back to when things were programmed in manual mode. You'd basically use it like as a new zero. So wherever your last hole was, you would just step across 1 inch from there rather than working out what it is from the origin.
It cancel out the first datum.
Yeah, yeah. If you were making a part on a manual machine, you would definitely do it incremental in most cases because you located your first hole using your gauges and everything to get it right. Whatever. So you set the dials back to zero or whatever that position is, and then you're cranking the wheel 3 inches this way, and when the dial lines up at 3 inches, you moved relative to the original hole 3 inches.
Yeah.
And
I mean, is this days gone by?
Days gone by, today, every day of the year,
So
people are doing that.
I mean, the incremental versus
absolute. Yep.
So the only thing I was wondering is with the calibration of the machine and everything, usually distance amplifies error. So if you're at an incremental point from 47 to 48, instead of calculating from 0 to 48, is there any logic to that?
Well, you're only as good as your initial setup.
Yeah.
Okay. If your zero is off to begin with when you do your first hole, all of your holes will be off. But they'll be off consistently.
Yeah. Hey, as long as it's consistent.
Yeah.
I reject your suggestion that we're inconsistent or that we're off.
Yeah. Well, speak for yourself. But it's funny though. So I'm going to take this back to the milling machine for a second. At the college, we have a room full of machines there, Bridgeports, milling machine, manual milling machines, CNC, the whole 9 yards. the kids fight over the machine that has the digital readout and the glass scales on it. Okay, because they want to use that one because they don't have to think as hard. So when they get their part mounted in the vise and they're ready to go and make the cuts and everything, they start out by touching the edge of the part and then setting it to 0. And if we're paying attention, they lift up the bit and they move it to half the diameter, or a radius, if you will, over. And now the center of the spindle's at 0. Okay. From that point on, when they're looking at their blueprint to do their work, it says, a distance that they travel, and they crank the handles over until the digital readout reads that number. And then they drill their hole or they mill or whatever. And they just keep repeating that process because they're in absolute mode while they're doing this, not incremental. When they set the 0, it absolutely knew that it was going so far over, and it didn't care. But as far as the guy who's sitting next to him on the machine that doesn't have the digital readout, he's almost certainly doing everything in incremental, because it just the way humans work.
Well, Tally and I were communicating this morning, and I do it all the time on setting up the touchpad, because I got a mobile touchpad, and I've got a laser pointer down, and it's 3 inches over, 4 inches back. And I just, put that put it into the MDI, and it's always incremental to there, and everything else is absolute.
Yep.
So no matter where the heck I'm doing it, it works. But
Yep.
I haven't heard that many people even ask about it before.
Yeah. We all use this now, not thinking about it, because it's in the software. It's kind of baked in, and we weren't paying attention, but it is there if you need it.
It's like GPS. You just put in where you need to go, and you don't even think about it.
Yep.
Yeah.
Unless you're in some muddy back road that you're going, okay, where is this thing taking me now?
Right.
Yeah. There's a lot of faith going on when it comes to GPS, and some of it's not deserved.
Right.
Yeah.
There was a bunch of cars got caught or got stuck on a muddy old construction road because the GPS told them to go there. Tow trucks made a heyday.
Yeah. Well,
look, at the present moment, I have a dislike or despise or whatever with Google and Google Maps, not because of its accuracy, but just because of their invasion of privacy. But I must admit, the Google Maps I've challenged, saying, I know the better way to go. You have no idea where you're sending me. And there have been times in the early days where Google has insisted that I drive off an overpass to get onto the motorway. And obviously that's not a smart thing to do. But as far as the other
depends
stuff
on your
goes,
vehicle.
you can't fault it on GPS. Yeah. And the suspension, you reckon?
Yeah.
Anyway. Google Maps is, I tell you what, it's the worst thing to use when you're driving a crane. It's you have now reached your destination. You be like, what? You be looking around.
Nope, I don't think so.
Right.
Of course, you're always into new construction zones that aren't even on there.
Right. Yeah. It just looked like a big old open area on the map, and it just have a pin like somewhere random. One time it sent me in a cow pasture. Like, I was like, what the heck? And I'm looking, I'm like, what? I'm like, y'all sure? Yeah. I said, can y'all just send me
get the message?
Someone address. Just send me someone address. Don't pin it. Yeah.
Yeah. We went out to Phoenix, Arizona, basically. And we were driving around somewhere, and I was taking my son to the movies at night. We're following the GPS, and we get downtown into a fairly nice area, and then it tells us to go down this road and take a left, and then continue on for 4 miles, and then it says you've arrived. We were in the middle of a desert on a little tiny road now, you know. And we're like, nope, this ain't it.
So what's your problem? You've arrived.
Yeah. Well, we never did see that movie that night. We went the following day. We went someplace to eat instead. But yeah, but that was 10 years ago. They've gotten better. Couldn't help but get better.
Yeah. You never say it can't get any worse.
Suggestions.
Yeah. We've been pretty much on topic tonight. This is unusual. What's going on here?
I was trying to find.
Let's start something else then.
Sorry, guys, I had to step out, but I was listening. So
yeah.
I have a funny one with the Google Maps. I always use the GPS to get on the highway coming down from Oregon Health Science University when I take the wife to the doctors, and there's a lot of road construction. So Google Maps usually gets me right onto the highway around the construction, no problem. So I'm sitting there I'm going down the road, and it says, continue straight through the park. I'm like, I don't think so. Wife's sitting there busting up laughing. We're getting told to go through all these different places. And I finally realized that we have it on bicycle mode.
Operator error.
I've had that happen to me, yes.
And we were just sitting there busting up laughing at the weird ass directions.
I've noticed now that when you're in the different modes, they do put it in like a breadcrumb or a dot mode sort of thing. So, but in the earlier days, it was the same mode. But yes, I've been caught on that one.
Yeah, I sometimes mine's going to I don't know how it does it, but sometimes it end up going walking mode.
Yeah, it was funny. It was.
So did you just finish doing a little more research on the ClearPath motors, and apparently every so many revolutions, or every revolution or whatever, there is a zero pulse.
Mm-hmm.
Okay.
So it does everything incrementally, but it absolutely knows where it's at. If that makes any sense. But that's why you don't need the
homing switches.
Homing switches.
Okay.
So I know, like I said,
was the 3D printed adapter.
Hang on, Steve. We're almost done.
Oh, yep.
So with the Tormach, there are no homing switches on the machines at all now. The ones with ClearPath, because it doesn't need them.
Okay.
All right. Now back to the microscope.
Yep. So this was the adapter I 3D printed. This before I cleaned it up. And I go to the other one here. Share. It just makes it sit way too high. That should be down into the machine, but I had to make the threads smaller so that it would capture it. But it's real weak. It won't stay in. It needs just a whole new piece.
You 3D printed that little piece?
Yeah, the little adapter piece.
Okay. What material do you use to 3D print it?
I just used PLA in that one.
Okay.
I just wanted to have proof of concept that it would work.
Mm-hmm.
That the mirrors and stuff were all in good shape. Nothing was cracked, nothing was broke, nothing was misaligned, and everything turned out fine. Amazing. Usually when they get horrible shipping no packaging with shipping, everything's way out of whack in alignment. And if you don't have the special tools to realign it all, you're SOL.
Let me ask you a question, Steve.
Mm-hmm.
That ring that you're showing right there now.
Mm-hmm.
Okay. That doesn't keep it up on the screen.
Oh, sure. Hit the wrong button.
Yeah, that doesn't have any mirrors or or lenses or anything
This
that depend
the
on
little
it.
adapter
It's
piece
just a
don't
little
know.
adapter piece, right?
But the tube has lenses in it.
Right. The tube is the other part.
Yep.
So this looks to be HDPE, high density polyethylene.
No,
Rather than
that's PLA.
the original was similar.
No, there was no original. This was just something that I
Okay.
could thread in to check the threads. Then I'm like, okay, well, because I used the thread file and a thread pitch gauge to drag, and at the thread pitch gauge, because I didn't have a M25 by 075 tap, so I just hand dressed it very slowly and got the threads to where a plastic piece would thread in.
Okay. This piece that we're looking at right now, is this the original piece that came in the microscope or no?
No, that
Okay.
piece is what I 3D printed.
All right. So the original lens screwed into the casting?
Yeah.
Okay.
Right here. This is
And
the
that's what's
upper piece
stripped.
here. You can see where it threads into the piece I made. It's actually just press. It actually just press fits because it's not. There's only like 2 threads left on it.
Right, but this throws it out of focus because it's too long now.
It's too long now, yeah.
Okay.
And this is focusable. This you turn this knob up on the top of the knurled area, and that slides up and down so you can fine tune your focus.
Okay, so in a perfect world, that lens part would screw into the gray.
Yeah,
directly.
Screw below the gray.
Yeah, directly.
Yep.
Okay.
Yeah, let me see. I've got one.
Yeah, that's not going to be so easy then.
Yeah, I've got one with the threads here. I dress the threads. Let's see. Okay. Threads are okay. They're not perfect.
Fellows, let me go. I will see
No.
So you can see how high.
There you go, Tally.
So the threads aren't perfect.
Is that a steel ring that is screwed in?
Huh?
Is that a steel ring that's screwed in from the bottom into the frame?
No, that's aluminum.
Or it's still aluminum. It's like screwed up in there and held in place, probably with high temperature Loctite or something.
Nope, it's just supposed to thread in. It just whenever it shipped, it got.
I don't think we're communicating.
Okay.
When they originally put it together, the two halves, I'm imagining that this aluminum part was machined separately and then added to this frame because of the gap that's around.
No, those are plastic covers.
Okay, well, never mind. All right. I would have to see it in person. So.
Okay, hold on a second. Yeah. I got an exploded view for a different model of microscope. Where we go?
Because it seems like to me you could have somebody with a lathe machine you a nice new piece of aluminum and take that one out and stick it in with the right threads and everything. Because then you'd be back in business.
Okay, they sent me the wrong microscope, but it's very similar in pieces. Share. Okay, it would be part number 23 right there.
Mm-hmm.
Fuck you. If I can zoom in on that there. That part number 23 there's got M25 threads. Mm-hmm. I can't really take off the binoculars.
Mm-hmm.
which are right here. If I take those off, it'll throw everything out of alignment. So getting it into a machine would be pretty difficult.
Gotcha.
So that's why I hand dressed it. But if I could get it, I was thinking maybe tap it out from 25, tap it out to 26, tap it out to 27, ream it out to 26, ream it to 27, and then tap it to 28.
All your swarf is going into the microscope, though.
This piece comes off with 3 bolts. I've already had it off. It's indexed with keyways, so you could take that whole top assembly off with 3 bolts and put it right back on. That's how I dressed the threads. I disassembled it because you don't want to mess up any of the optics and mirrors down in here. The prisms and stuff. You don't want to get dust inside of it as much as humanly possible. But it's repairable. It's just got to figure out how much I want to spend and time I want to put into it. But
I'd machine a whole new part.
it's a cast part. It would be a lot of work. I don't know how to draw it up. And then I don't have the alignment tools to take the binoculars off and realign them. So,
all right. Okay. Sometimes the right to repair doesn't mean we have the ability to repair. Because
we have the right to try though.
Yep. The threads were saved. The threads were saved. I looked with the thread pitch gauge and everything. I dressed out all the impinged points and a plastic piece threads in. So all I need is a focus tube, the C-mount tube. It's either that or I punch it out to 28 millimeter and thread it 28 millimeter. Then I can just use regular, normal, standard parts. But that would be hard to do by hand to get it perfectly straight, square, and center.
Okay.
Well, I'll get it figured out one way or another. It won't go to the junk pile. It's a good base. So.
I want to know what Ned is doing now.
I'm just assembling my Z-axis, and there's nothing like a good feeling of a good, firm, machined fit that everything is square.
Yeah.
I took it into one of the engineering shops and I machined the backs of these so as that the Z-axis rails are perpendicular, or whatever, to the X-axis rails, and all the spacing was done spot on. So it's just a nice, beautiful fit on there. Everything's aligning nicely. It's just a nice feeling. Except my screws are too long, so I've got to go get shorter screws in a few minutes, or shortly anyway.
Very cool. And we can see Ned's 5th axis table, trunnion table, sitting in the front foreground.
That's the rotary. What's it catching? Shit, now it gets on. Yeah, so that's what's going on in the machine, but over on the side over there.
Very good.
Yeah, it's gonna be nice.
No, she should be a beauty. I've got a pile of work lined up for it, so that's one of the reasons why I'm pushing to finish it. Yeah, I've got I haven't tried it yet, but one of the jobs that if it does do it will be thousands of 3mm holes into 8mm 316 stainless if it'll do it with a carbide bit.
Fantastic.
If anyone's ever drilled 3mm holes in stainless to see what it's like. So I've got to work on the speeds, constant pressure with a carbide bit so they don't get chipped. Yeah.
Yeah, you don't want to work hard in the steel because stainless bad that way when you heat it up.
Yeah,
So you
like
got to make
the
it
whole
through.
works. Yeah.
Yep.
Yeah. Now I'm just doing the boring part of tightening all the rail nuts.
You could have a channel on YouTube where you did nothing but doing that, and folks would watch.
I know. People pay for weird shit on some of those things. The other one is Twitch. Like, I can't believe people pay to watch somebody else play a game.
My son does it. I don't understand it, but yeah.
Yeah. It's sort of like all those people that go and watch a football game or something.
Anyway,
Yeah, this
fellas, go ahead, Steve.
This is the Open SCAD right here. It's really simple so that a monkey can do it. I mean, you just type in, if you want to make that 23 millimeter, you type in 23 millimeter and hit play, and it resizes it for you.
Mm-hmm.
So you can go 24.9, you can go 20, 26, and then just hit it, and it resizes everything for you. And then it just spits you out an STL to print.
Mm-hmm.
And somebody wrote this for doing camera adapters, and I've used it to adapt Barlow lenses and stuff. So it's kind of cool.
That's amazing. Jeez.
And Open SCAD, anything you find on like Thingiverse that's customizable, it's all done in this Open SCAD. So
yep.
Jeez.
Yeah, I love parametric programming like that, where you just change the variable and you've got a new
yeah,
design.
It's simple. You don't have to learn a whole friggin' 1,000 menus to get to one function.
Mm-hmm. Yeah. Oh, interesting. Well, gentlemen, it is getting close to the witching hour. It's 9:00, and I know this is the time when all your brains work the best and you come up with the coolest information at the last minute. So I'm giving your brains the opportunity to do that before we call it. Yeah.
Come on, Ned.
No,
I was about to say, what are you guys looking at me for?
Yeah.
Well,
the usual suspects.
Since you were asking about that, I'm going to share this one thing here. This is not the right model, but that's a drawing of the tube. You can see you got two, part number 10 and part number 9 are lenses.
Mm-hmm.
But that's basically what it needs to be at M25 by 75. But the one I have, it's a separate piece that screws in. It's got another set of threads up at the top. So, but they sent this one. It's the wrong one for the wrong model. But
yeah,
I can make that with my file.
Well, before we go, just a little bit on what we're talking about earlier when we're talking about steppers, servos, etc. Something that I picked up on, and because this machine is going to be closed loop steppers, is a standard stepper motor operates at around about 4,000 millimeters a minute. A closed stepper motor you can get double the speed out of. And I've tested on mine after watching a guy on YouTube. I was getting up to 8,000 millimeters a second on it comfortably, and then after that, obviously, it's the servo. So, even if you were to change to a closed loop stepper motor, you'd get a bit more RPM on the rotary. I just don't know how to translate it into. I guess you'd divide it by 200 or whatever it is, and yes, so you'd get probably double the speed from what you're getting now if you had closed loops, Milo.
Yeah, I mean, I haven't exceeded 400 RPM. Haven't needed to. It was already starting to scare me.
Oh, look, you don't. Oh, the fact that you're cutting with a spindle, just
gives you the best of both worlds, owning a lathe, and that's what I'm working towards on this here. After seeing your, the only thing I don't have is being able to adjust the angle of the table like you can. But yeah, no, I've played around with a woodworking lathe, and it is a lot of fun, but it would get boring. I can't see myself making bowls, but I could see myself making 8 balls or round dice though.
Well, and the RPM that I would use on the lathe, I'd normally be around 15 to 1600 to 1800 RPM, once you get it balanced. But on the lathe, I'm never above 300. The only time that it would be, if you didn't have a lathe, it would be nice to spin it at about 1100 RPM for sanding. 300 is just a little too low.
Too slow.
Yeah. Where about 1000 to 1200 RPM is a comfortable sanding speed.
Well, there you go, guys.
Yeah, no, it's it. Yeah. Bill wants to go. Bill's always the party pooper.
Yeah. That's why I started this, so I could have a party to poop.
There you go.
Yeah, party pooper. That's yeah.
I'm heading to the Thursday the Tektronix. I haven't been in 20 years to the Tektronix surplus store, so that's going to be fun to see what new stuff they have, interesting things they have there. So
fantastic.
Yeah, get one of those. Yeah, get an oscilloscope while you're there.
Yeah,
I've got a few.
Tomorrow I'm heading to the East Tech Manufacturing Technologies series in Springfield, Mass, and that's going to be a blast. Last year there were several manufacturers with CNC router tables there, and there were literally 100 different manufacturers of machine tools like milling machines and vertical, horizontal, the whole 9 yards. So it's at a state fairground in 4 or 5 different buildings, and it's going to be a blast. So can't wait for that. So I'll send pictures and maybe a quick video or two.
Post pictures. Some of those trade shows are fun.
Yep.
Seeing all the new interesting stuff.
We've got nothing exciting happening over here.
Yeah.
So sorry about talking over you, Stephen. I didn't hear you start talking until a few seconds after I started.
It's all good. That's what it happens on these.
All right, folks. Thank you, everyone, for coming to the CNC Router Mixer. We appreciate you more than you could know doing this. It's just fantastic getting us share information with all these great minds here. And I look forward to it. If you want to join us next week at 7 p.m. Eastern Time, we do this every Tuesday night. Thanks, everyone. Have a great evening.
Bye.
Bye.
See you later, guys.